So in this video, we're going to be looking at radicals. Uh, so the basis of radicals, there's a few terms you have to know to get started. The first one is the radical symbol, which is our root symbol here. It's represented by a sort of line. Our next term is our radicand. Our radicand is the number within our radical symbol. That's the number within our radical symbol, number or variable. Our index is our type of radical, which we will look at as well. So our type of radical. And our radical is, of course, all these pieces together. So this is sort of what a radical looks like. Square root of 72. Here the index is 2, and usually we don't write the index. If our index, when we don't write our index, we assume that our index is 2. And in this example here, number 3, we have written our index is 3 because we it's different from the index of 2, so we have to represent it with the number 3. Okay, so in our first example, we're going to convert our entire radical. This is our entire radical. Our entire radical is when our x value, there are no numbers outside our radicand or our radical symbol, and our radicand is inside our radical symbol. This is a mixed radical here because we have a number outside our radical symbol and a number inside our radical symbol, which is our radicand. Okay, so in our first example, we're asked to convert our entire radical into mixed radical form. Mixed radical form. So the basis of radicals is we can do the prime factorization of 72, 36 and 2, and 6 and 6. And we need to find our largest perfect square of our number, which is 72. In this case, our largest perfect square would be 36 because 36 is also 6 squared. So we have 6 squared. Sorry about that. So we have 6 squared times 2, which is also 36 times 2. And now when we have a perfect square, because we have an index of 2 and we have something to the power of 2, we can take one of that number outside our radical symbol. So we're left with 6 square root 2. So we find our largest perfect square of our number, which is 72. That becomes 36 times 2. 36 is also 6 squared. We are left with 6 squared times 2. Because our index is 2 and we have a 6 squared, we can take out one of that number. So it will be 6 square root 2. Alright, so moving to our next question, which they're asking us to convert 3 root 7 into an entire radical. So when we're converting a mixed radical, this is a mixed radical. When we're converting our mixed radical into our entire radical and we have an index of 2, we have to square the number outside our radical symbol. So in this case, I would uh, say 3 squared and I would put it inside my radicand. And I would put it inside my radical symbol. So I would end up with 7 times 3 root, 3 squared. And now I know 3 squared is 9, so it's 7 times 9, which is also square root of 63. That's my answer. Now if I want to work backwards, my prime factorization of 63 is 9 times 7, 3 and 3. So we're left with 3 squared times 7. And now, because my index is 2 and I have a 3 squared, I can take one of that number out. So I'm left with 3 root 7. So that's working backwards from mixed radical and putting it back into an entire radical form. So when we have x of 2, we would square our number outside our radical symbol and put it inside a radical symbol, multiply it along with our radicand, and then we end up with our answer. So our next question, we're dealing with cube root. When we have an index of 3, it's called a cube root. And So in this question, we're asked to convert the cube root of 108 into a mixed radical, into the mixed radical form. So what we would do here, it's similar to um our square root, but we have to remember the cube roots and our perfect cubes. So 3 to the power 3 or 3 cubed would be 7, and 2 cubed would be 8, and that type of thing. So our 108, we would prime factorize our 108, which would be the first thing we would do. We can do 108 divided by 27, and we get 4 times 27. And now we are left with 9 times 3 and 2 times 2. Our 9 simplifies into 3 times 3. So we're left with 3 to the power 3 because we have 1, 2, and 3 3s, and we have 2 2s. So we have to times that by square. And now, because we have an index of 3, we can take out a number when we have a cube root. Perfect cube. So in this case, we do have a perfect cube. Uh, because of that, we can take out one of that number. So we can take out a 3 here. So we're left with 3 cube root 2 squared. And now we can simplify this into 3 cube root 2 squared, which is 4. So just another quick question we can do here. We are asked to simplify cube root 8 root 324. Cube root of 324. They want us to convert this into a mixed radical, our mixed radical form. So pause the video and try to do this on your own, then come back and then begin. I can show you how to do it. Alright, so first thing we would do is find our prime factorization so we can find our highest uh, cube, perfect cube, highest perfect cube. So we're left with 81 times 4 will give me 324. My 81 becomes 999. Now I have 3 times 3, and my other 9 becomes 3 times 3 as well, and I can drag my 4 down here. Those are my terms right there. So I'm going to group 3 of the 3's together. So I'm left with 3 to the power 3 times 3 times 4. Cube root of 3 to the power 3 times 3 times 4. So what do we know about cube roots? Well, when I have a number to the power 3, I can take one of those numbers out. So there we go. Take that number out now, and I'm left with just 3 to the power 3. 3 times 4 is 12. And if I want to simplify 4, of course, it would have been 2 and 2. Sorry, I forgot to do that. So 2 and 2. But as you can see, we don't have 3 of the same number, so we cannot take out any number. So our answer would be 3 cube root 12. So that was radicals.